why do we bias amplifiers, or why do we check the bias of an amplifier? So let's start with a hot bias. So for 6v6 single-ended class A, which is typical of a Champion 600 or a Fender Champ, you know, the plate dissipation is going to be higher than, or is going to be 12 watts or higher. So what does that mean? So that means we have a lot of headroom in the amplifier. So the sine wave represents the signal coming out of the preamp. There's no clipping. It's never going to exceed these two lines here. If it's biased cold, you know, that could be less than 90% of 12 watts. It's going to look something like this. The signal coming from the preamp will actually clip. So some people like that. It's a matter of taste. And then what most people want to do is something in the middle, where it's not clipping all the time. Occasionally it will, and that'll create an interesting tone. So let's go ahead now and figure out, how do we calculate what the bias is and how do we relate that to the plate dissipation of 6v6. Here's our single-ended output. We've got the 6v6. It's got a plate, goes up to B+, and we've got a transformer that couples across to the speaker. 4 ohms, which will reflect about 5.5k, but that's not important. More importantly is that we have a cathode bias resistor here, and then we have the input from the preamp. So there's our sine wave that we used in the previous drawing. And nominally, this is factory set at 470 ohms. So if we're to calculate the bias, we need to work out a wattage, which is P equals I times V. And V is going to be V plate. So that's going to be the voltage here minus the voltage across this resistor, which we call V bias. I is constant all the way down. So if we can calculate I flowing through this resistor, we know what I is at the plate. So what we'll do is we'll measure V across this resistor, which will give us our V bias. And we can calculate I as I equals V bias over 470. So that gives us our total value for I. And then we'll measure here, which will give us our V plate. We'll subtract V plate minus V bias, and that will give us our wattage. And we're going to compare that to what's in the specifications. So let's take a quick look at the specifications. I've got the Sylvania tube manual out, and our amplifier single-ended, so it's a class A. And the plate dissipation, as we said in the first diagram, is 12 watts. So we need a number around that or less than that. It can be higher, it can equal it, and people do like to run the tubes hot, but you're going to have to replace them more often. I prefer a hot amp to a cold amp because you get much better headroom, but then of course the trade-off is cash, because you're going to have to buy more and more tubes and be replacing your tubes more frequently. So let's see how close the amp is to 12 watts. This resistor here next to the cap, this is our cathode bias resistor, and I've got the probes across, and I've got the ohm meter currently measuring 457 ohms. So expect at 470, you know, we have a tolerance. So that is actually the true measurement. So let's take a note of that, and now let's go on to do the next measurement. Without removing the probes, I can now do my next measurement, and that is measuring the voltage across that resistor. And I've allowed the amplifier to warm up a little bit, and the number seems to have settled on 20.4 2 volts DC. So I'm taking a note of that, and now we need to do one more measurement before we can calculate it. And this is where it gets dangerous. So working on tubes amps is dangerous. There are many lethal voltages within this amplifier that can kill you instantly. Always keep one hand in one pocket, or give the amplifier to a qualified person. So before I even move the probes or touch anything, what I'm going to do is discharge the B+ by placing this probe on here. And just watch that voltage go down from 20 volts to 0 volts, which is good. And so I'll just keep it on a little longer to make sure everything is discharged. This area here is the lethal area of our amplifier, so we need to be very careful. All right, so that looks discharged. So let's set up the next measurement. I'm allowing the amp now to warm up. You can see I've changed this, so this remains ground, but this is on pin 3 of our 6V6, which connects to the transformer. So we're going to measure the voltage at pin 3, and it's now nicely warmed up, and I'm getting 365 volts. So let's take a note of that as well. 365 volts, which is good. Here are the measurements. So the bias resistor, or B, was 457 ohms. The bias, or the voltage across that resistor, was 20.4 volts. The ohm sign correct. And not the cathode, the plate, VP, was 360 volts. So let's subtract VB. Let's subtract VB from VP, so that's going to give us about 340 volts. And also we need to calculate our current, or I, running through the circuit. So I equals V over R, which is 457 divided by, 457 into 20.4 volts, which gives us our current 45 milliamps, or this number into this number equals 0.045, which is 45 milliamps. So our power dissipation at the plate is 340 times 0.045, which equals 15 watts. Ouch. So that's pretty hot. So what we're going to have to do is increase this resistor. You know, it's supposed to be 470 and it was measured at 457, so there's a 30 ohm difference there, or a 23 ohm difference already. But I think I'm going to start and add a 200 ohm resistor and then do some more measurements. So we'll look at that in another video of how we tighten up the bias of the amplifier and get to a point where we are not over clipping, or the power amp is not clipping too much, and we've got nice headroom, but we're not, you know, blowing the tube up. So that's the end of our video for this week. Please like and subscribe, Calsonics, and I'll talk to you next time. Thanks a lot.